All right. Hi, everyone. I want to get started first just with a question. So it's a rhetorical question I have to answer. So what if the most malleable identity in the Azure environment is not a user? When we hear about an attack in the Azure environment and start thinking about users, maybe there was a compromise to a global admin, a subscription owner, some other highly privileged users, right? For maybe other identities such as a service principal. But we tend to assume that attackers initialize their compromise to a highly privileged user or an identity. But what if this wasn't the case? What if instead the compromise came from a low privileged user and instead targeted a workload identity? Today, I'm going to show you how managed identities attached to serverless resources in Azure can actually become a path to privileges their compromise user never ever had. But before that, let me introduce myself. My name is Manuel Melendez. I call me Manny. I work at Microsoft as a security researcher. My focus or my line of work is on Azure Cloud Stack of Research. And I spend a lot of my time building, simulating, and validating a lot of real world scenarios like the one I'll be showing you today. In my free time, I like to play video games, guitar, spend time with my 5 dogs. And this is my first time here at BSides, so I'm really excited to share here. So let's get started. Today, we will be covering the following. So we're going to go over managed identities in Azure, what they are, why are they trusted, serverless resources. I'm going to focus specifically on function apps, logic apps, and automation accounts, and how they work, and the same for their identities. Some attack paths based on these same resources I'll be talking about, starting from initial compromise all the way to compromising the identity to abuse their accesses. Then a demo with a tool that I'll be showing you later, based on one of these attack paths. And lastly, some mitigations on how to detect and also reduce the blast radius from these attacks. So let's start. First, let's define what are managed identities. It is simply an identity attached to an Azure resource that it's used to basically authenticate and access other Azure services. Simple as that. The nice thing about managed entities is that there's really no credentials to manage. There's no secrets, no passwords and certificates. Azure handles all of this for you. And there's 2 different types of managed entities. So the first one is system assigned. Basically, it has a one-to-one relationship. So you assign it to different resource and it's dependent on a lifespan of that resource. Then we have user assigned managed entities, which are standalone identities and they have a one-to-many relationship. So one of these can be attached to multiple resources and they're independent from the lifespan of these resources. So why are they trustable? So they're a security feature. They're implemented by Azure. Everything is handled by Azure. So they're proficient and everything. So, and like I mentioned, there's really no credentials involved. So there's really no passwords to leak, rotate, or disconfigure. And because of all these reasons, there's some implicit trust by organizations. So they're trusted within their organization, their environment. And they tend to grant them privileges for their other resources and access whatever valuable information they may have, right? But if you think about it, this is where they become a target. Because anything in a Azure environment with permissions may become a possible target for an attacker, especially if they can identify this resource has actually higher privileges or they can access something that I'm interested in. So now, where do these managed entities tend to live? I'll be focusing on serverless resources, but there's other resources in Azure that can have managed entities attached to it. So a serverless resource, it's basically a cloud managed resource where you don't really have to focus at all on the infrastructure. You just deploy it and it's ready to go. The main focus of these is that you just deploy or insert your code or your workflows. You're ready to go. You just execute it. And I'll be focusing on the following. So the first is logic apps. There, you can say an orchestration workflow where, and actually we'll see this in the demo. You can actually set up the steps, the action, the order of the workload that is going to perform. There's different actions and they're usually exposed through HTTP triggers, but there's other kinds. Then we have function apps. They're the event-driven pieces of code. Basically, you upload your own function, same thing with your code, and they're exposed through HTTP endpoints. So when you access this endpoint, it executes the function that you're calling, and then provide whatever output you're trying to get. And then lastly, we have automation accounts. These are just like the name implies, based on some automation schedule or some trigger, also some basis. And for these ones, you create a new robot where you just deploy your PowerShell or Python scripts. And these are used often for administrative automation. So all of these resources, they're typically used by organizations for a variety of tasks, such as ticketing, deployment, or a variety of other different purposes. And because of all of this, they may likely will be accessing other resources. And because of this, they tend to have a managed entity attached to them. So now we know what are managed identities and where it can live in a Azure environment. So how can an attacker actually abuse these managed identities? So here you have some examples or the resources I mentioned. However, the interesting thing here is that, like I mentioned, there's really no credentials to manage, right? But from an attacker's perspective, who needs credentials when even better can actually just get an access token for these resources or their identities. So, the idea here is that each of these resources can interact with their identities, and it's a built-in function that you can actually, or these resources can actually request an access token for their financing entity. But it's not that the user can actually just interact with it. It's not like I just go to the portal or call an AK in or an AK and it's just like, oh my God, I get a token for this identity. Not really. But the identity or the resource of themselves can do it. So the idea here is that if I as a user can somehow manipulate the workload or these resources, I can influence how they interact with their identity. In other words, I will use it to manipulate the workload and actually execute some actions that will request an access token. I deploy or run to execute that logic. And then I just extract the token and then start abusing it. So now, let's say we steal a token. What can we do with it? So the answer here, it's really medius, or it varies really. It's not like, oh, just because you got a token for one of these identities, you can have control over your entire environment. But it's tied to whatever permissions you have granted to your managed entity. So you can go all the way from just reading some secrets that may contain something valuable, accessing something in a storage account, maybe being a contributor for an entire resource group. So maybe you have actually access or control over a lot of different resources inside a group. Maybe it be used by an attacker for some lateral movement to continue your attack inside your environment. But the interesting thing here is that if we do this, we're really not breaking identity. So if we steal a token, we're not really breaking identity. And we're just using a feature, a system that it's intended to be done, right? So we're really using or manipulating it just for our own benefit, which is to steal a token for these resources. So now I'll be going over some attack paths for all of these resources. You'll see that the first and last steps of these attack paths are pretty much the same. So it starts up with some initial access. So we compromise whatever user somehow. We don't really know how. I don't know what their credentials got exposed. I don't know, was phishing, whatever, right? So first, as an example of how to manipulate the workload and execute, I'm going to go over function apps. So let's say our compromised user has a contributor role for this resource. And with this, what they should do to manipulate the workload, it will be to either modify an existing function or create a new one. And in this case, they can use it to call directly on an entity endpoint to request an access token. So you modify the workload. Now all we need to do is a function apps. It's just act as if we're calling that HTTP endpoint for the function. And then the output will contain the token, which is extracted. And now we can proceed to that use, right? So an attacker would, with that token, put in over whatever permissions they have, and then maybe explore whatever other resource now they have access to. Now for logic apps. This is the one we're going over for the demo. So you'll see the one more in practice. For this one, like I said, logic apps are orchestration workflows. So you specify which actions are taken directly on your workflow. So action A, etc. If there's some triggers, if there's some modifications, some access to other resources, etc. For this one, all we need to do, either we can modify the entire workflows, as you'll see in the demo, or we can simply add one new function or new action, or we just run some code in order to call something using the managed entity and then again extract the access that will be used for this action. And then it's just a matter of running that action, seeing the output, which will in the Adobe, in the UX abuser. And then for automation accounts, same thing. So we have, in this case, access to our automation account. So we could just create a new runbook or modify existing one. And this one is more straightforward because these runbooks, basically, you just upload your Python or PowerShell scripts. You do so in such a way that, again, they will be calling some identity and home and request an access for your identity. And then you just retrieve that or run it and then before you code, then So now I'm going over a demo. Again, like for the logic app attack code that I mentioned, I'll be using this tool, MS Invader. Shout outs to my good coworker, friend Mauricio Velasco. He's the author of MS Invader. I added some new functions for these resources. And all you need to know about this tool is that it's a simulation tool where you create your playbooks and you specify whatever actions you're going to be taking your scenario. So just to give you more visual attention here, these are our resources. Use in the order. So first let's start off with a compromised Azure San Antonio. They happen to have contributor access or role or a specific logic app. This logic app has a system assigned managed entity. That entity had access to this keyboard in the treasure chat, which itself contains some secrets. So the important thing here is to know that's the order and following, but regarding a relationship, that's exactly what like that. There is no other relationship. So this user doesn't have access to the keyboard or anything, doesn't have access directly to the same managed entity. And well, that's it for the explanation. So now for the demo, on the left, we'll be seeing my label for Program Visualizer. And then on the right, just to show you visually how it looks on the Azure portal. But it's pretty much the same on both. We're using the same identity. Okay. Well, so yeah, the first thing we're going to be doing is authenticate as the compromised user using device called cloak. That's the customer user, San Antonio. So again, is the compromised somehow? We don't really know how, but so the first thing we're going to be doing is to enumerate logic apps in the environment. So as we can see, we try to add to it, and yes, we can see here. I know it's kind of small fire, but so we found one LA order problem for, which is the one that I shared before, and it says here it does have a system assigned managed entity. And just to show you visually if it looks in the portal, as that's the user, we're going to try to access that logic app. Let's go to logic apps. It all shows one name. That's it. In the GLUM system resource book, but the user Excel actually doesn't have access to it. So they only have access directly to the logic app, and that's it. And we're going to verify that it indeed does have a system assigned managed entity on right there. So the next thing, just to show you again the permission for capabilities of this user, we're going to try to enumerate for access the keyboard that we mentioned before, the target keyboard. So here we got an error. So it says forbidden cover that offers home action on resource. And this was for the KD treasure chest keyboard that we mentioned before. So as you can see, this user, and also on the portal, if we go to keywords, there's nothing to show. So this user doesn't really have access to any of these resources or secrets or anything. And that's what we're trying to ask, right? So what are we going to do? Like I mentioned before, is if we have access, we have logic app retriever access for this keyboard, for the logic app, we're going to modify it. And we're going to add some code in order to obtain an access token. First, I'll show you the current workflow of this logic app. So this is used, let's say, by some legitimate users in organization or whatever sense, right? So you can see, like I mentioned, very visually, you actually see what order and what actions are taking place here, right? So with MS Invader, we're going to do two things pretty much simultaneously or one back-to-back right away. So we're going to be modifying this entire workflow in order so that there's only just one trigger, and then we execute some action to get an access token. And we're going to run immediately that same new workflow to get the token. So I'm going to refresh here executor right there ends there. And I'm going to refresh my browser so that you see the new workflow. And as you can see, now there's only just a manual trigger, and then some action that gets to away. I'll show you the logic right now. But first, we'll see the run history, the latest one that we run. And already on the left below, you can see that we got the token. LP secure, their token right there. So you may be wondering how this works. And it's pretty simple, actually. We go to the code preview. The logic here, it's super simple. So all this is doing is basically just holding a speak get request to this URI http://headers. And we're authenticate as a managed entity, specifically with the audience or default P9. So basically what this does, in other words, is that for this URI specifically, when you post a request here, all it does, it returns the headers from your own request. And since we authenticated add managed entity, the header will contain the access token, which is what we're getting back. And that's why you saw it in the output. And then another layer, just to show you visually, I extracted directly the token. So now, we got the access token for this managed entity. What can we do with it? Just for the sake of time, we already know that it has access to the keyboard. So that's the action that we just tried to do before to access the keyboards. We're going to do it again, but now this new token, again, as a managed entity. And so now we get a 200 response code, meaning that it was successful. and it said that I found 4 secrets. And we're going to try to enumerate them. So yeah, their own 4 secrets. The first one is supply, BSides San Antonio. There's an API key, storage account, access key, and whatnot, right? So we found some valuable files or secrets here that we can then continue to use in our environment. And so just lastly, to, I guess, cover our tracks as an attacker, what they do, of course, it's not perfect, but to reduce some suspicion, we're going to reset the workflow to what it was before, right? Just in case some legitimate user comes back and sees the logic as, and they're like, oh, what is this? Why is there a get token bucket here? So again, we return it to what it was before, just in case somebody want, right? Of course, if they go back to the run history, if they had the logging, if they had their logging enabled or some alert, for sure, like they can detect it, right? But just on the surface, right? Like if we just return it to the current state, really, unless we see something suspicious, there shouldn't be any alerts, right? Agree. And the last dialog was pretty much done a demo just to show you visually. Here I use another tab to my admin account for this environment, just to show you that keyboard indeed does exist in the environment, right? That didn't really get up. So that's the resource for Google Unsu. It has K treasure chat. That's the one we just expropriated. And very quickly, we're going to call objects, secrets. And these are the 4 secrets we expropriated over here. B. And that's it, pretty much for it. So, just lastly, I'm just going to go over some mitigation strategies for these types of uses or uses, if you want to call them. So the first one is to restrict access. This one applies mostly for function apps. So we're restricting or requiring authentication for your HTTP triggers. This is in case, let's say, your endpoint for a function somehow got exposed. Somebody shared it with who they were meant to. And so, because for function apps, as long as you have the URL, you access it. And if it's anonymous, you can just access it and call the function, right, to execute whatever it has. Then we have network isolation. Of course, I guess it's the most obvious one. So in your organization, only allow the people where they should be able to then execute these workflows. And of course, using private endpoint. Then we have the least privilege principle, which in simple terms, it just means to don't overgrant permission, right? Don't go away giving away contributor or owner roles to anybody. So only grant whatever you may, right? Maybe some users only need to read some workflow or something, or maybe just execute it and not be able to actually modify the entire thing. And then lastly, we have enable monitoring. So it's just about enable your diagnostic settings, maybe possibly creating some alert for these actions, right? Although for these two, I'll go more into detail, lastly. So going back to the least privilege principle, this is again an example for function apps, but this is also applies to other resources as well as users, right? So let's pretend we have one single function app that it's a contributor for an entire resource group. And this resource group happens to contain storage accounts, keyboards, VMs, databases, whatnot. So with just one single access token, they can already access all of this. So imagine our previous demo where it got compromised. It wouldn't just be one keyboard, right? It would be all these resources for just one single resource that got compromised. So instead, something they do is actually scope it or whatever tasks they need to be used, right? So maybe having 3 separate function apps, maybe each of them has their own functions or accesses, and also their imagined entities should have different permissions. Maybe one of them should only be able to read a storage account, another one be a VM contributor, whatnot, right? And then lastly, what should you monitor? So you enable your diagnostic settings, you enable logging for all these actions. These are just examples, but basically what you want to understand from this is that be on the lookout for modifications for your logic app work tools. Same thing for your functions, like if there's any new functions added to your function ads, or the same thing for your robots and automation. And then also you see any triggers for your URLs, your function apps. Same thing if you see any workflow executions for your logic apps, and then also for your automation routes. And so lastly, just some key takeaways. And also cover a lot of different topics, but these are the things that I need to remember. So the first is manage identities, remove secrets. So there's the credential, like I mentioned, but they're trusted or by a lot of organizations. And like I mentioned, there's a variety of reasons why. But remember, if an attacker can somehow be able to modify the workflow for any of these resources, most likely they can, and show you in this demo, they can access or they can get an access token for one of these managed entities. But just because it gets compromised doesn't mean they already take over your entire resource. Your entire environment. It means they only have as many permissions as the managed entity has. And lastly, to reduce blast radius, remember there's the least privilege principle, network isolation, authenticating endpoints, and also remember to enable your logging and creating alert for suspicious activities. And that is it. Any questions?
When the token is sold, they should have the additional access that could be applied with all the tokens used.
Yeah, that's right.
So with the token itself, the artifact is still, there's no conditional access bill could apply to the token use. So like function
A can't use function B's token or
No, they're separate. Unless maybe it's a user assigned a managed entity that has access to multiple resources, but in this case, it was for system assign. So system assign to help.
so the system has it. You extract it from the system
Yes.
and used it outside the system.
Not really outside of the system. I'm still getting that token. So basically that token, it's the same that was provided for the identity. So I'm just stealing it and using it as if I was a managed entity.
you have an OAuth token that you're then asserting and then another another system.
And there was no conditional check doing is in it.
Well, you were already granted with a token, and that was for the managed entity. So there was already so about it.
Please, there's no check on the token. There's check.
Oh, for the token. No, not really. You were already granted.
Yeah, like once I had that token, I can do whatever.
Yeah, exactly.
Again, there's no policy. What?
It depends on how you configure your environment, I guess.
Something is there a one? Yes. Hey, this license of it. Okay.
Any other questions? All right, thank you. Let's give it a
Got it. What?